Welcome everyone to the community question roundup with Ramesh Gulati and myself, Ryan. I'm the CEO and founder of Upkeep. As everyone knows, this is part of the maintenance community podcast, and it's for a podcast for people who want to learn all things about maintenance and reliability. In this episode today, we're going to be reviewing questions submitted by the members of our maintenance community Slack group. We're going to hear insights from one of our maintenance experts and residents, the Reliability Sherpa himself, Ramesh Gulati. You ready to jump in?
Yes, sir, I'm ready.
So again, today, Ramesh and I are super excited to dive into some real questions asked by the community members. One thing that I personally love is these questions range from anything from very, very high level questions that go into very strategic discussions within the company around maintenance, reliability, and operations. And they also go into like some very ground level problem solving questions at the same time. So super excited to dig in. Let's get started, Ramesh. The first question that we got asked by Abdu, what are some of the elements of a great reliability program?
Hey, it's a great start with a good question. A lot of people ask the same thing. How do you start a good reliability program? What's a reliability means to you? Think about what reliability means to you. Let me tell you my part. What I think is reliability means to me. To me, having a high reliability or reliability excellence, what that means is assets are performing as designed with no or minimum failures. Let's think about that. How make that happen? Assets are designed with high reliability, or really I call it RAM square O, RAMSSO. Reliability, availability, maintainability, safety, sustainability, and operability. So when assets are designed from that perspective, it means they're highly reliable, easy to maintain, easy to operate, safely can be operated, also sustainably. Many companies we are working silos. Somebody else designs it, somebody puts the capital projects together, somebody buys it, and then that asset comes on the floor. When we are putting special requirements, specifications, design being done, we should get in more, review those designs. So I think my suggestion is really get in more, and also this is the time I would say that read 10 Rights of Asset Management book. It talks about the whole process from planning, specification, design, building, installation, and commissioning. Second, have an effective PM program based on FMEA and RCM philosophy. If you're having a good maintenance PM program, means you are catching things during inspection, during the PM, you're catching things, and then you have a corrective maintenance program to correct those findings. Okay, so you're doing those. Again, I can talk hours on this subject, what a good reliability program should be. So I think in a limited time, they should be good enough to for this question. Okay.
You dropped a lot of great nuggets there, Ramesh. And the one thing that really stuck out to me was really about like assets basically performing to the design specifications.
Yeah.
And I think that's something that people often forget because it goes directly into, tracking metrics, downtime, reliability. But really like the big question is, what was it designed to do?
That's right. What the objective was and how it was designed, what it was supposed to do. Is it doing it?
Yeah.
If not, then we got a problem. That's kind of thing.
Yeah. We've got another one from Jozhi, who asked, in VFD-driven pumps, how important is it to set the duty point? If a duty point is not set, what are the consequences? So we're getting really deep into variable frequency drive. So Ramesh, any thoughts on this one? This is
yeah, I think it's a very, very specific question to VFD. Now, let me explain to some other people who don't know what VFD means, variable frequency driver. Why we use that VFD? It helps us to really reduce the speed of this drive unit so we can change the flow or pressure. So really, VFD helps us to reduce our energy cost. Usually what you look into is your pump performance curves. You have to match so you're not going below the performance curve with the speed. So those kind of things. So you need to have a flow rate or speed and see where the curve, the performance falls down so you don't go down below that. And also sometimes it's better to change the impeller size reduce it. That may be another way of doing things. So I think I would highly recommend to talk to some pump expert or VFD, wherever they bought that, why is that they are asking that to do. So I think I will refer to a pump expert about this question in detail. Okay.
Jozhi also asked, can one predict the exact failure period based on collected vibration uptrending data?
Yes, if you have a good data, you are trending and you have a good history, you may be able to maybe predict what is going to happen. Again, vibration data is a very complex data. It's not easy. Are you measuring displacement, velocity, or acceleration? Each of those things tells you different things. Like a displacement is a more telling you is a imbalance. It's kind of a more at 1x speed will tell you there's some problem with the imbalance. 2x kind of tells you where the misalignment or those kinds. So you have to learn a lot in this vibration. To me, vibration analysis requires a lot of skills, and you have to take your time to learn. And may have to go to school and get certified or something and to learn it. So if you have a good data and you understand what data is telling you, yes, you can predict that.
I totally agree with that statement as well. Like there's so much great data that you can pull from vibration. One, you have to trust it. Two, you have to have the expertise to be able to understand it. So third question for today, Samir asked, from your experience, what are the best systems to record OEE elements and effectively monitor OEE of production equipment? Is your EAM a suitable solution? What do you think, Ramesh?
Really doesn't matter. Any CMMS system, upkeep or any EM system or any quality management system can work. Think about, we know OEE has three major component factors: availability, performance, and quality. What's availability? Availability is uptime and all the downtime. So we need to go and get that data, how we can get uptime. Where is the machine uptime? Where is that coming from? Where is the downtime? We need to know that. Same thing, you have to think about the performance level, what their performance levels are. Then also, what about your quality, where the scrap rates are. So all these different element data points, they should be there available to you. I don't care they are in this system or that system or that system, as long as I can pull them out easily. I don't have to hunt for them. Those are available, and then I can make the calculation.
The one thing that I'll add here, and obviously I do have a little bit of a bias here, Ramesh.
Sure.
But one of the things that I guess like and also dislike about OEE is because, yes, it is just a single metric. And yes, you can pull all of this data and it's a great metric to track. But what I want to really push for within maintenance reliability teams is that full life cycle feedback loop. So what I mean by that is it's not just about tracking OEE. It's also about how we take this information, drive action from it to ultimately improve OEE, because our goal is not really just to monitor OEE. Our goal is to, constantly improve. And when I see things like, okay, how can we best monitor it? It loses the most important piece to me, which is, what are we going to do? What are the actions that we're going to take based off of, the metrics that we see and look at every day? And the reason why I'm a little bit biased here, Ramesh, is because ultimately because the way that I see it, your EAM, your CMMS is ultimately responsible for helping drive some of the actions within your team. I think what we're getting at here is it's important to have and house this data. It doesn't matter whether it's your quality system, doesn't matter whether it's in your CMMS. But I think what you and I are absolutely aligned on is make sure you do something with this. And the place where you can make the biggest impact is ultimately what actions you're going to take off of this data. All right, Sahat asked, who are the key stakeholders in order to build and implement a successful proactive maintenance strategy?
If a maintenance asset fails, who get impacted? Think about that. First thing, if asset is down, who gets impacted? Your operation, your maintenance. I mean, these are two key players who get impacted because somebody has repaired it or somebody's not producing something. So those people are key. But there may be some other people in a broader way. You may have some other quality may be impacted, maybe finance may be impacted because they are not making money. We are not making money. But I think you have to start thinking if asset goes down, who are get impacted, or those people are your stakeholders. You need to get them involved in your building your maintenance strategy.
I kind of love that as well, Ramesh, because it helps prioritize as well, like who are the most important stakeholders. The simple question of like, who's going to be banging on your door, calling you first when you have a breakdown? Right. Like, and that's kind of how you prioritize it, because you could say it's important to get finance, procurement, it's important to have maintenance, like, but asking that question helps also prioritize who's the most important stakeholders.
That's right. I mean, again, then you start putting priority. Hey, you want 20 people, you want 4 or 5 people, or 6 stakeholders whom you can talk. So then you can prioritize which are more important. Then you go from there.
Next question up from our group, we got Joe Martin asked, I'm in the process of transforming a reactive culture to a proactive one with my maintenance team, but it's been proving to be difficult. Any tips on making this process more effective and a little bit more smooth?
Unless until you have a right culture at your place, any improvements won't work. Any changes, they won't stick if you don't have a right culture. If people have not accepted that change, boys, you try. And creating the right culture, it takes time. Anytime you want to make this cultural change, again, you have to find who are the stakeholders there and try to work that stakeholder one by one. Education, training, those are key things. People have to understand why they want to change. I mean, why should I change? Why should I do this new thing if it's not going to impact me? Yeah, you go change. I'm not going to change. It's not impacting me. I think to having a right culture, and that requires a lot of education, lot of training, and a lot of time. And again, think about, again, I said 360-degree kind of thing, going up and down, sideways, both ways, all 4 ways. You have to you have to educate your boss, you have to educate below down who are working, who are your peers, both sides.
One thing that stands out to me, Ramesh, that you just mentioned was that the question that you asked, Joe to ask the rest of his team, which is, what's in it for me? Yeah. And I think when you think about changing people's motives, and let's call it like culture, it's all about like people's motives. And when you approach this problem by trying to address what's in it for me for each person within the team, I think that'll actually help shift the narrative about why we're doing what we're doing and help everyone communicate essentially like this proactive culture within the team. And oftentimes too, like the what's in it for me comes also from like a very selfish, and that's okay, selfish reasoning. What's in it for me? Less stress at work. I get to go home on time, less fires, less phone calls, more predictability. And if you approach it from that perspective of each individual, what's in it for them, again, can kind of like change a lot of people's perspective on this shift from reactive to proactive. All right. Good luck, Joe. We're rooting for you. All right. Richard asked this question. I'm preparing to build a new building for a nonprofit. We're trying to decide what type of HVAC system we should go with. 2 options right now, VRV and VRF. In your opinion, what type of system would be best to go with?
To me, it doesn't matter whether you are for profit or for nonprofit. Whatever assets you have, whatever building asset you have, a best practice should help you out, okay? Now, this VRV and VRF, basically, they are, say, variable, is a volume as well as variable, flow. So both are same system, basically. So my approach for this kind of thing, what I've done in the past, really looking at the life cycle cost analysis. If this system will like 15 years or 20 years something, let them run a 20 years life cycle on it. How much is it going to cost you to operate? How much is it going to cost you to maintain? And look for 20 years what's going to happen when you have replaced a major component, all these kind of things. So by doing a life cycle cost analysis on this for 15 years or 20 years, then decide which system is a more cost effective, and that's what system you should be going. So I think that's my approach would be doing life cycle cost analysis on 2 or 3, 4 system, whatever your supplier gives you. You tell them whatever your requirements are, give them and let them suggest you, hey, what they think, and then go from there.
Next question we've got comes from Bob Stevens. He asked, what are the top 10 key information points to know when organizing a maintenance plan?
What the key information is, data point or what, I don't know. So let me give you answer different way. We need to know how we can make our maintenance organization effective and have what information we need for that. Okay. So let's think about that way. That's the way I'm going to answer. Okay. Now, to do, first thing is I need to know all my assets, what asset I own, and is all of them are listed in the CMMS system. Now, I need to know what are the critical assets I have. Again, for that, I need to establish criteria having a how I'm going to define criticality. Again, I may not have resources to do everything on every asset. That's the reason I need a critical asset list. So I can prioritize work. Hey, these assets, 20% or 30%, or these are the next level, whom I'm going to spend a lot more time because they're critical to my operation. Then also I need to know I call it a nameplate data. You know, what motor, let's say take a motor, a 60 horsepower motor, or 100 horsepower motor, or 5 horsepower motor, that's not good enough. We need to have nameplate data because motor, when you're ordering or you need to replace something, you need to have a frame size, you have to have a shaft size, the key weight, all those kind of things are important. Those I call the nameplate data. So that data also should be in a CMM system. Then we have to define system asset hierarchy, how the hierarchy location-wise and function-wise, how that way that extends. That ensure all work orders, all work done on the machine, on asset, whether it's a failure fixing, corrective maintenance fixing, or preventive maintenance, or condition-based, whatever we are doing is documented on a work order in a CMM system. So we know how much really is costing that asset to operate and maintain. Some of assets you may not have it, means you may decide to go run to failure. That's more economical. However, you need to mention that in CMMS system, document that this asset does not have a so-called PM plan because we have determined it's run to failure philosophy of that. So there's a lot of things. I mean, again, you have more than 10, I told you more than 10 things, you know, but you need to start thinking what key information means. And if you want to have effective maintenance management program, so you need to have all of this.
We've got the next question from Zee. Zee asked, although we're in the 4th industrial revolution, I feel like we're still lagging behind. We haven't digitized enough. Why do you think this is so? What technologies should maintenance and reliability teams focus on?
Digitalization is a great tool to help us to get better. However, if you don't have a fundamentals ready, your people don't understand why planning, scheduling, all, having a spare part, it really doesn't matter. You need to get your fundamental rights and then start thinking how you're going to digitize all of those things. Yeah, there's definitely benefits of going to digitalization, using smart sensor, IoT, all those kind of things, but you need to have people understand basic principles, basic fundamentals of maintenance and reliability, and then these are the advanced tools that should be. Make sure your people understand fundamentals, why they're doing it, why planning and scheduling, why having this data in CMMS is important. Again, digitalization to me also means that how we can make sure is easy to input the data in the CMMS system, water system.
So I see this as like two different aspects. One is like from the aspect of like lagging behind because of the people, the culture, being able to drive the change internally. And I think that's largely what you're talking about. The other component to it, and I actually blame technology companies themselves. And I think in many ways, Ramesh, it's that technology has actually lagged behind in this industry. We look at all the technologies built for consumer applications. They are light years. They are decades ahead of where technology is and should be for a lot of the industrial workforce. And I think we're going through this transition, this period right now, where we are starting to see more venture capital, more innovation go into industrial companies. And I think that's a very, very positive thing. In terms of why, well, I think one is I feel like we're lagging. The answer is yes. It's not just you, but it's the entire technology industry as a whole. And then go ahead, Ramesh.
Sometimes technology company, they come up with this, hey, digital twins, make that, hey, that's going to take all our problem out? No, still there. That's another tool available in our toolbox to help us do a better job, to identify the problem easier, quicker, but that's not going to solve our, problem, or it's not solve all our issues, just, so I think people also, some technology company, oh, here's my tool, use this tool, it's going to solve all your problems. And they tell, oh, this is going, it's going to implement your asset management. Oh, no way.
And again, very biased here. When we talk about fundamentals, again, like, for me, like, instead of trying to implement like AI, machine learning, like, goes back to the basics. And to me, the basics really start at like, where is your asset data stored? And again, I'm very biased here, but it all starts with having a basic CMMS. And what we find is that there's so many companies out there latching on to the new shiny object without fully utilizing their existing CMMS, their existing EAM. They're only scratching the surface of what it can and what it should be.
If I know, talking to people, hardly any company uses more than 40 or 50% capability of any CMMS system.
The next question we have is from Irete. He asked, what kind of job opportunities do you foresee for reliability industries, and how the job opportunities will be impacted for the renewable energy industry? So obviously lots going on in the renewable energy industry, lots changing. Right. What do you think, Ramesh?
To me, in my mind, it's going to open a lot more opportunities. Okay? It's going to open a lot more opportunity because each those applications, if you go take a wind or tides or waves or geothermal, we have not explored those, like solar power now. How big that industry going to be? It has become now. We're going to replace them. We're going to make mass production of those solar cells. And that's, again, is really opening up a lot more opportunity. To me, hey, that's another area. Again, we have to skill ourselves a little bit different. We have to start thinking, how can we can learn that industry and get knowledgeable and do something in that industry, learn it, okay? To me,
I could not agree more. I mean, I think this is so interesting. There's so much interest going into renewable energies right now. And when I think about like the differences of, let's call it like wind, solar and currents and whatnot, it just has like a completely different set of challenges around reliability. Where you could be in very remote places operating assets that are supposed to, essentially like be running for decades with very, very minimal human intervention. And I think that's just like a very interesting new set of problems versus like static assets in a facility. We're standing, less than a couple feet away from them on a daily basis. And something else that just came to mind too is when you're in a plant, you can kind of control the ambient, environment around your equipment. For renewable energies industry, it's,
it's outside. You're all outside, and it's going to be challenged how to take care of those things.
Very interesting. So I think that this is just going to be a really interesting opportunity for everyone in the industry today and those that will get into it in the future.
Yep.
All right. So that actually rounds up all the questions for today, Ramesh. I just want to thank you one more time for taking the time to answer all of the community members' questions. If any of the listeners would love to get answers to some of their maintenance reliability questions, just join our Slack group at upkeep.org. You can receive live answers from fellow members or also hear from Ramesh himself. Again, my name is Ryan. I'm the CEO and founder of Upkeep, and I hope to connect with you again, and we'll chat again soon, Ramesh. Until next time.
Thank you, Ryan, and I enjoy it, and I hope I can help people to answer. Again, I don't know everything, but I'll try to do. If I don't know, I'll let you know. Hey, I don't know, but I'll try to answer what the best of my ability. Thank you very much for getting me engaged.